when you say probability, if it's a cloudy day, don't you say that there is a chance, right? There is a high chance that it might rain. Carry an umbrella if you're going out, right? On what basis you're saying that carry an umbrella, it might rain? Because it's from the experience, looking at the sky, the way the clouds are. People say that okay, there is a chance, higher chance that it will rain. What is an experiment? Experiment is process which results in some well-defined outcome. Okay, process which result in some well-defined outcome. That means you take a coin, you toss a coin. What is the probability that you will get a head or you will get a tail? You understood my question? 50%, because it might fall head up or it might fall tail up. So the only possible cases are two possible cases, either head or tail. So two possibilities are there. Understood? Only two possibilities are there, either head or tail. So this is called an experiment. So there is a fixed outcome, either head or tail. So that it's a fixed outcome that you know. That is called an experiment. So a process which results in some well-defined outcome is known as an experiment. What is well-defined outcome? When I toss a coin, I might get a head or a tail. There is nothing else that will come. Similarly, you play dice, right? When you play snake and ladder and all that, you throw a dice. So what are the how many sides are there in a dice? 6 sides. So one side will come up, but which side will come up? We don't know, right? I mean, either 1, 2, 3, 4, 5, or one of the 6 sides will come up. So, or throwing a dice is also an experiment because it has well-defined outcome. It can be 1, it can be 2, 3, 4, 5, or 6. So that's also an experiment. Now, random experiment is that all the outcomes of the experiment are known in advance. That's called a random experiment. Giving an example, tossing a coin is a random experiment because there are only two possible outcomes, which are head and tail. That is relatively important. So sample space means when I throw a dice, what are the possible outcomes? I list out all the possible outcomes. Say, for example, here sample space is denoted by the letter S. When I throw a dice, I can get a 1, 2, 3, 4, 5, or 6. So this is a sample space. All the possible outcome, or that is called sample space. So when I toss a coin, what are the possible outcome for tossing a coin? When I toss a coin, what are the possible outcome? It can be a head.
Heads or tails.
Heads or tails. It can be a head or tail. That's all. Now assume that I have got 2 coins. I have 2 coins. So 2 coins I'm tossing together. So what are the possibilities for 2 coins tossing together? So first time, 4 possibilities are there. So first time when I throw, I can have both heads coming up, or I can have first one coin having head, other coin having tail, then another coin having tail, then the first coin having head or tail, then the order matters, then both are showing tail. So these are 4 possible combination possible. This is the sample space for when 2 coins are tossed at once. Equally likely outcome. Equally likely outcome. When you throw a dice, all the 6 sides have equal chances of coming up, right? Or equal probability of coming the top position, right? So can I when same thing with when you toss a coin also. When you toss a coin, you don't know whether head will come or tail will come because it has 50-50 chances. So when they have equal chances, when an outcome to happen, when equal equal possibility is there for an outcome to happen, then we call it as equally likely event. All the events, all the possibilities, all the outcomes has the same chance to happen. If it has the same chance or same probability to happen, that is called, those kind of things are called equally likely outcome. Now, assume that I have a box, I have a bag, whatever. Now, in that bag, I have some blue color balls, some 5 blue color balls, and I have 3 red color balls. Keeping my eyes closed, I want to draw one ball. What is the possibility that a blue ball will come? What is the possibility that a red ball will come? Do you think that is equally likely?
No,
No. Why no? Why no? Why do you think it
because
is?
blue color balls have more like are more in number.
Yes, blue color balls are more. So the probability of picking a blue color ball is more than the probability of getting a red color ball. So here, in this case, they are not equally likely. They are not equally likely. Understood? So in the case of tossing a coin, it is equally likely because the possibility of head coming up or tail coming up are same. So in such situation, we call it as equally likely events. In this case, it is not equally likely because some are more than the other. Okay. Now, what is an event? An outcome of a random experiment is called an event. So if I say, what is the probability of getting the heads when I toss a coin? So
50%.
50%. That is an event. I am talking about one specific situation or one specific condition. Or when I am throwing a dice, I am saying that what is the probability that the number that is appearing is more than 4. You're understanding. So when I am, see, in the case of a dice, when I throw a dice, it can 1, 2, 3, 4, 5, or 6. One of this can appear. All of them are equally likely. So event is, I am talking about one specific thing to happen. Say in this case, what is the probability that the um, number is greater than 3? What is the probability that when I throw a dice, the number that appears is greater than 3? This is an event. That number that appears on the dice is greater than 3. That is an event. What is the probability? Probability, you can write that also. What is the probability? Probability of an event. Probability of an event denotes the likelihood of its happening. Probability of an event denotes the likelihood of its happening. And you denote probability of an event like this: P of E. P is probability, E is event. P of E is equal to probability of the happening of event E. Probability of the happening of the event E. Now, what is the formula to calculate this? Number of favorable outcomes divided by total number of possible outcome. Possible outcome is the sample space. Okay, total number of possible outcome. Probability of getting a head, tossing a coin. While tossing a coin, this is how you write it. So probability, in bracket you write the event. Probability of getting a head while tossing a coin. Sample space is head and tail. Okay, this is the sample space. So total number of possible outcome is 2. What is the favorable outcome in this? How many favorable outcome are there? What is the favorable outcome? Getting a head while tossing a coin. So how many possibilities are there? Only one possibility, right? Here, only one H is there. Getting a head while tossing a coin. So one is the favorable outcome. So if you ask me what is the probability, you will write it as number of favorable, maybe I'll write it here. Number of favorable outcome is 1. Number of possible outcome is 2. So probability of getting a head is equal to 1 by 2. Now, so here, number of favorable outcomes in this case is 1, right? So such events are called elementary event. So you can write that also. An event having only one favorable outcome is called an elementary event. So here, getting a head while tossing a coin is an elementary event because number of favorable cases is only one. Okay, only one head will come. So that is called an elementary event. Probability of E, here E is getting a head. Okay, getting a head. Then E dash is not getting a head. Okay, E dash is not getting a head. That's how we treat it. So one is probability of happening one case. E dash would be probability of not happening that case. P of E, where E is getting ahead, then in P of E dash is not getting ahead. Okay, so what are they? So E and E dash are called complementary events. Complementary events. If one is happening, another one is not happening. That is the example. And what you need to understand is always probability of E plus probability of E dash will be 1. Probability of happening plus probability of not happening is always 1. You know probability of E, which is probability of getting a head is 1 by 2. Then you can easily calculate probability of E dash, which is 1 minus 1 by 2, which is again 1 by 2, right? The sum of probabilities of an event and its complementary event is always 1. Impossible event and sure event. Impossible event means when you know that that event will never happen, that's called an impossible event. Say, for example, the chances of it raining today is 0. It's not going to happen. So that's an impossible event. If the probability of an event, equal to 0, the event is called an impossible event. Okay, so here probability of that event is going to be 0. Now what about sure event? Sure event means you know that that's certainly going to happen. That's called a sure event. So the probability of an event equal to 1, the event is called certain event or sure event. So the probability, it is always varying between 0 and 1. It can never go negative. A probability of an event can never go negative. It can never go above 1 also. Okay, you can either say maximum is yes, it will happen, or it will not happen. So it will not happen means probability is 0. It will happen means probability is 1. There is nothing beyond that. So always probability will vary between 0 and 1. This is very important. And I have seen this question coming in MCQs. Bag contains a black ball, a red ball, and a green ball. All the balls are identical in shape and size. Mohit takes out a ball from the bag without looking into it. What are the probability that the ball drawn is a red ball, black ball, and a green ball? So first of all, you need to know number of balls in that bag. How many balls are there in that bag? Right? Total number of outcomes. In probability language, you can write total number of outcomes is 3. Probability of red ball, taking out red ball, is how many red balls are there? That is the favorable outcome. Okay, so favorable outcome is what is you can write number of favorable outcome, divided by total number of outcome. Total number of outcomes. So favorable outcome is how many red balls are there? Only one red ball is there. So you write 1. Number of favorable outcome is 1. Now total how many balls are there? 3. So write 3. So probability of a red ball is probability of taking out a red ball is 1 by 3. Similarly, what would be the probability of taking out a black ball? How many black balls are there? Only one, right? Only one black ball is there. So here also number of favorable outcome is 1 because only one black ball is there. Out of how many balls? 3 balls are there. So 1 by 3 is the probability for a black ball. Now probability of green ball is also same because they have given only one green ball. So 1 by 3 again. You have a box and it has got say 4 blue balls, 2 red balls, and say 1 green ball. Okay, so in this case, what is the probability of taking out blue ball, taking out 1 blue ball? What would be? So you need to check how many blue balls are there. How many blue balls are there? That is the favorable outcome. 4 blue balls are there. Now in total, how many balls are there? 7. So you should write 4 by 7. That's the probability. Now, if I say probability of red ball, so favorable, how many favorable outcomes are there? How many favorable outcome means how many red balls are there? 2 red balls. So 2 by 7. Now probability of green ball is 1 by 7 because only 1 ball is there.
If there's a bag and there's only 3 balls and all those 3 are red, and if
Then
they
it's a
ask
sure
find the
event.
probability of taking a red ball, so
It's
what would be
1.
like 3 by 3?
3 by 3 is 1. Yes, it's a sure
So
event,
1.
right? You are picking up only that ball. That ball is definitely going to be, it's a sure event. You are going to pick up a red ball only.
Okay.
Got it, right?
So we write
So
sure event.
it's a sure event. Yes, it's a sure event. And that's 1. In a single throw of a dice, find the probability of getting a number. See, you have to find the probability of getting a number. Probability greater than 2. Then probability less than or equal to 2. Then, I mean, you can write less than or equal to 2 and all that in words, okay? Next is probability not greater than 2. So I can write not greater than 2. I can write like this also. I mean, but better to write in words. Okay, so when you throw a dice, what is the sample space? What is the sample space when you
1, 2, 3, 4, 5, 6.
1, 2? It is always written in set notation. Okay, so that is why I'm writing using set notation. Sample space is written using set notation. So there are 6 possible outcomes. Fine. So let me write total outcomes are 6. So that is the same thing for all the cases. Okay. Now, greater than 2, a number greater than 2. What are the numbers from the sample space which are greater than 2? Which are the numbers?
3, 4, 5, and 6.
How many are there? 3, 4, 5, 6. 4.
4.
Right? So I will write 4 by 6. Reduce it, make it smaller. I will write 2 by 3. That's my the probability of getting a number greater than 2. Probability of a number, taking a number lesser than or equal to 2. Look at the sample space and decide the favorable outcome.
2 by 6.
2 by 6, yes, because the favorable 1 and 2 are the numbers that are satisfying this event. So 2 by 6 is nothing but 1 by 3. Probability not greater than 2. What is the meaning of not greater than 2? What is the meaning of not great? A number not greater than 2.
1 by 3, right?
Same thing, no, 1 and 2, right?
Yes, ma'am.
So it is again 2 by 6, which is not greater than 2 means not 1 and 2 are the favorable outcome. 1 and 2. It shouldn't be more than 2. That's what they are saying. In other words, not greater than 2 means only 1 and 2. So 1 by 3 is the probability. Deck of playing cards consists of 52 cards, which are divided into 4 suits of 13 cards each. 52 cards are divided into 4 sections. They are, what are they? Spade, diamond, hearts, and clubs. Okay, so 4 different sections. Spade, hearts, then diamonds, diamonds, and clubs. Okay, so each of them, under each there are 13 cards. In total 52 cards are there. Under each of this 13 cards are there. Okay, and how are these 13 cards divided? Each of them has got A, then 2, 3 up to 9. Okay, then there is a king card, and also yes, 10 also. Okay, I missed it. 10 also. A is 1. 1 to 10 you can say. In the place of 1 we write A. 1 to 10, a king, queen, and a jack. So these so 10 plus 3, 13. So under spade, hearts, diamonds, and clubs, this is how cards are divided. There are 26 cards are red and 26 cards are black. This also you should remember. How many king cards will be there in a deck of cards?
4.
4. How many queen?
4.
4. How many jack? 4. A also 4. Then numbers, each of the numbers also 4 each. Okay, so that's how you should keep in mind. Now shall we start doing 4th question? What is meant by a face card? What do you think is a face card? Where do you see a face in the card? A and number cards have face?
No.
No. Face card means king, queen, and jack. So 3 cards. 3 cards in each set. When I say set, I meant under spade, 3 cards. Under hearts, 3 cards. Under diamonds, 3 cards. Under clubs, 3 cards. So in total, 4 into 3, 12 face cards are there. In a deck of 52 cards, 12 face cards are there. Okay. So look at the question. From a well-shuffled deck of 52 cards, 1 card is drawn. Find the probability that the card drawn will be a face card. Second, not a face card. So here will be a face card. You take it as probability of E. Then not a face card. You take it as probability of E dash. You have learned it, right? What you have learned? Probability, sum of complementary events. Sum of probabilities of complementary events are 1. This you know. Now, probability of getting, probability of the face card. In a deck of cards, there are 52 cards that you all know. There are 52 cards in a deck of cards. Then, in a deck of 52 cards, okay. Now here, how many face cards are coming in total? 12 face cards are coming. So, number of favorable events are 12. So 12 by 52, you make it smaller. What? 13. So what will be the, that is not a face card. Not a face card you can do in 2 ways. One is 52 minus 12 by 52. Understood? From 52, you subtract the 12 cards. Only 12 cards are face cards, right? So remove the 12 face cards. Then what you are left with? 40 by 12, 40 by 52. That would be 10 by 13 is what I'm getting. 40 by 52. Same thing, can I do like this? 1 minus probability of E, which is 1 minus 3 by 13 equal to 13 minus 3 by 13, which is 10 by 13. Both ways, this way and this way. I can do any which way. Which part are you confused, Malin?
Ma'am, like how did you get 12?
How many face cards are there in a deck of 52 cards? How many
Okay, ma'am,
face
so-
card? What is meant by face card? You
I
understood the face card? King, queen, jack.
Yeah.
Okay,
ma'am.
those are face card. So how many are there? Under spades, there are 3. Under hearts, there are 3. Under diamond, there is 3. And under clubs, there are 3. So 3 into 4 gives me 12.
Okay.
So 12 favorable outcome. And
Okay.
total outcome, how many cards are there in total? 52 cards are there in total, right? So that's how number of probability is number of favorable outcome divided by total number of outcome. 12 face cards are there divided by 52. Total number of cards are 52. So that's how I get 12 by 52. Understood? Now not a face card. It is 52 minus 12 by 52. Or you can do, this is 2 approaches I have done. This is one approach. This is second approach. Always write probability of E equal to number of favorable outcome divided by total number of outcome. Write that step.